Hello, I'm going to take you through isomerisms in coordination chemistry. So, first of all, let's look at number one. What type of isomerism? What type of isomers are these two complexes? So, you could see that we have NO2 here and ONO here, indicating that from the first complex, we have nitrogen coming first. From the second complex, we have O coming first. And you know that NO2 can also be written as ONO. But in terms of ligands, the name of this is nitro. And this one is nitrito. Nitrito. So this ligand is an unmediated ligand because at a point we can have nitrogen donating a lone pair of electrons to form a bond with a metal atom. There can also be a point where we have oxygen donating a pair of electrons to form a complex with a metal atom. But mind you, one of these occur at a time. There can be a point that nitrogen will be donating a pair of electrons and oxygen will also donating a pair of electrons to form a complex with a metal atom at the same time. Only one of them can do that at the same time. So anytime you see NO, nitrito, NO in a complex and you are looking for type of isomers, there is a high possibility that you can find linkage or ligand isomerism. So if you see something like this in the presence of an ambidentated ligand, so you are going to get linkage or ligand isomerism. So these two complexes are linkage or ligand isomers. Let me give you another example of ambidentated ligand. A ligand that has two donor atoms, but only one of them can donate a lone pair of electrons at a time to form a complex with a metal atom. So one of them is SCN, which is thiocyanide. At this point, we have S coming first, sulfur coming first, meaning that this S is the one that has donated the lone pair of electrons to form the complex. Anytime the one that comes first is the donor atom. So there can also be a point where we will have N coming first. At this point, N is a donor atom. In this case, we call it isothiocyanate. So anytime you see these kind of ligands, an ambidentated ligand in a complex, so be highly expecting linkage or ligand isomerism. So let me clean this. So that is a trick to look out for a ligand isomers. So the second one, let's look at the second one. The second one, you could see that we have copper here forming a complex with ammonia. Sorry, cobalt here forming a complex with ammonia, copper here forming a complex with cyanide. And here we have copper. Instead of cobalt forming a complex with ammonia, we have copper forming a complex with ammonia. And here we have cobalt forming a complex with cyanide instead of copper. So you could see that the two different metal atoms, they've exchanged their positions. So they've exchanged their positions, indicating that um, these are coordination isomers. So anytime you see the two different metal atoms in a double complex exchanging their positions with ligands, so you should know that the pair of the complex, the complexes are exhibiting coordination isomerism. So we are done with this. Let's look at this. For this one, what are you seeing? you could see that we have sulfur in here, bromine outside here, bromine inside here, sulfate outside here, sulfate. So you could see that SO4 and bromine has exchanged their positions. So we have a counter ion and a ligand exchanging their positions. What is outside the coordination sphere is called counter ion. So this is the counter ion, this is the counter ion as far as outside the square bracket, the coordination sphere. So counter ion and a ligand exchanging their positions gives us what? Gives us ionization isomerism. So these two complexes exhibit ionization isomers. Sorry, these two complexes are ionization isomers. So let's look at this. What are you seeing here? What are you seeing here? We have water as a ligand from the first complex, and from the second complex we have water as a ligand and water as a water of crystallization. So the water is outside the square bracket, the coordination sphere, so is generally water of crystallization. So water is acting as a ligand from the first complex, and at the in the second complex, we see water acting as a ligand, and at the same time, water of crystallization. So the type of isomerism exhibited here by these two complexes is hydration isomerism. So these two complexes are hydration isomers. So isomers, hydration isomers. So these two complexes are hydration isomers. So you could, if you check very well, you could see that hydration isomers are a typical type of ionization isomers. But in this case, we have ligands, alternating with we have water exchanging, acting as a ligand and acting as a water of crystallization too. Here we have water inside. We do not have water outside, but here we have water inside and water outside too. So this is hydration. These are hydration isomers. So that is it. I have a full video on this which contain detailed explanations and coordination isomerism. So kindly check it out. It contains both the structure and the stereo isomers in coordination complexes with a lot of examples. So kindly watch it and then you'll be okay. So if you like this video, kindly subscribe to my channel and share it with your friends too.